So today we intend to finish on what we are discussing, and we will look at the multiplier concept. That is what we are discussing, and I said that a multiplier is the number by which the national income changes due to a unit change in its component. So this definition is very key in defining what a multiplier is. So it is simply the number by which the national income changes due to a unit change in any component. So we understand the components of the national income. So for example, consumption is one of the components of income. So we may want to know by how much the national income changes if consumption is increased by 1 unit. So the number by which consumption changes as a result of a unit change in consumption is what we refer to as a multiplier. Now we said that equilibrium or at equilibrium, so the income is equal to what? To consumption plus investment. We have consumption is given as A plus Y, and of course we have investment, which is the autonomous investment. So from here we can find the equilibrium national income. So you know how to find the equilibrium national income. So you can rearrange the equation. If you are given, so you can find the equilibrium national income. That the equilibrium national income is simply given by consumption plus investment, which you have here. The first part is consumption plus investment. So you can factor out Y, there. And what you get, the equilibrium national income is as so. Just divide both sides by 1 minus beta. 1 minus beta. So you get the equilibrium national income as 1 plus investment over 1 minus beta. This is the equilibrium national income. Now, suppose the autonomous investment increases by I. So what will happen to the equilibrium income? So we have now the new income and the previous income. So if investment changes, so our new equilibrium will be the new income plus the old. So we have said it's a change in element. So our previous equilibrium income is defined by this part here. So you can add the change in investment, which is this component. So our new equilibrium will be given by this. So if you factor out this now, you find the change in investment over 1 minus beta. So if you deduct this, open up the brackets, this is what you get. And therefore your Y will be 1 over beta into I. Then we can find the change in the income over the change in investment. So that means you find the derivative of that function, of the income function you have here. So the change in income over the change in investment is simply equal to 1 over 1 minus beta. So that simply gives you the investment multiplier. This is what we refer to as a simple investment multiplier. So that means that if you change investment by 1 unit, then income will change by 1 over 1 minus beta. And this is what we refer to as a simple investment multiplier. So we can have a look at an example. So suppose you have income is given as 100, investment is 25, and then the marginal propensity to consume is 0.5. So remember, in our multiplier here, beta simply refers to the marginal propensity to consume. So beta refers to the marginal propensity to consume. So the change in income will be given by this. So you can find the change in income. So we said the change in income would simply be equal to the change in income will be equal to the multiplier times the change in investment, or times investment in simple terms. So we have our multiplier. So we need to find the change in y. So the change in y so our change in y will be given by, so you can check back here. So the change in y is given as 1 over beta times investment. That is what we have here. So you can cross multiply here. You can multiply here and get the change in y. Now, our new y would be 125. Now we can find the investment multiplier. So from this simple equation we have, so we said that the change in y over the change in investment is actually 1 over 1 minus beta. You know what is 1 minus beta. So the change in in y over the change in I. So we have said beta is 0.8. So to find the investment multiplier, simply 1 over 1 minus 0.8. 1 minus 0.8, which is simply equal to 1 over 0.2. So 1 over 0.2, so you can multiply that. So that simply gives you 5. So that tells you that your investment multiplier is 5. So you can see it here. So the investment multiplier is 5. So alternatively, you can divide change in income over the change in investment, which is 125 divided by 25. So it gives you 5. So that simply tells us that the multiplier is 5. So what does that mean? That if you change investment by 1 unit, then the national income will change by 5 units. So you can see that. That is how we compute the simple investment multiplier. Now, suppose now we extend this investment to include the induced investment. So remember we have used the multiplier that does not have induced investment. So we have only used the autonomous investment. So in this case, so the induced investment depends on income. So if we have an investment function defined by this, which is I is equal to I naught plus Y. So Y is the induced investment. And we also have the marginal propensity to invest. So we can now derive another investment multiplier is the extended investment multiplier. So if we have the investment function and we also have the consumption function, this is what we have. So our investment in this case, sorry, our income will be defined by this function. So which is the first part is the consumption and the second part is the investment function. So get the like terms together. So take beta y and y to the left hand side. So if you do so, this is what you will have. Now you can solve, or you can factor out y. Factor out y. So if you factor out y, so this is what we'll have. Now, I think there is a small omission. Now, there is a lambda here. Under the investment function up here, I naught plus lambda y. So there is a lambda there. So it is supposed to be I naught plus lambda y. So there is a lambda here. There's a lambda here, so that when you factor out y, this is what you'll get. So your equilibrium income will be 1, sorry, that is alpha plus autonomous investments divided by 1 minus beta minus alpha, sorry, minus lambda. Now you know what is beta and you know what is lambda. So beta is the marginal propensity to consume, and the lambda is the marginal propensity to invest. Alpha is the autonomous consumption. So from here you can tell, or you can find the multiplier, the extended multiplier now. So if we increase now the autonomous investment from this part here again, so we have our new equilibrium given as y, that is the old income plus the the change in what? Income. Or sorry, the change in investment. So you understand this part. This part is simply the old equilibrium, sorry, the old income. The second part is the change in investment. So this part here is the change in investment. So the new income is actually made up of the old income plus the change in investment. So you can see this. So from here, you can now reorganize, open the brackets, add, subtract, and make y the subject again. So if you open that, this is what you will have. So this part here, this one will cancel with this one. So if you open up the brackets, this part here will simply cancel with this one. So that what you have now, the new equilibrium income will be given by the change in investment over 1 minus beta minus lambda. This is our new equilibrium. Now from there we can find the multiplier. So we can find the multiplier from that expression. And I've said the multiplier is given as the change in income over the change in investment. So the change in income over the change in investment will simply be 1 over 1 minus lambda minus beta. This is our new investment multiplier. I hope you can see that, and also you can follow how we derive the multipliers. So that is for investment. So we said investment is one of the components of the national income. So we can move on and also look at the multiplier with government spending. So in our previous discussion, we have not included government spending in computing the multiplier. Now, if we are given this, that the national income from the expenditure approach, so it is given as the government is given as, that is the national income is given as consumption plus investment plus government expenditure. So this one can be equivalent to consumption plus savings plus taxes. And remember, at equilibrium, these two should be equal. So which simply means that investment should be equal to what? To savings, and the government expenditure should be equal to taxes that are collected. So this one is an equilibrium condition, that investment plus government expenditure should be equal to savings plus taxes at equilibrium. Now, that means that y, that is, we have the autonomous or the induced government expenditure. You can call it YD. But the induced government expenditure is simply Y minus D. And in this case, YD is actually referred to as the disposable income. So our income model would be alpha plus beta into y minus t plus I plus t. Now the y minus t is simply the disposable income. So if you open up the brackets now, you'll have this alpha plus beta y minus beta t plus I plus g. So you can rearrange again that equation and make y the subject. So take y to the other side. So you'll have 1 minus beta in brackets y should be equal to alpha minus beta t plus I plus t. So you divide both sides by 1 minus alpha. This is what you get. So the equilibrium income will be given by this function. Now the coefficient 1 over 1 minus alpha is the multiplier for the government expenditure. Now if we can find the change in income over the change in government expenditure, then we have our government expenditure multiplier that we are discussing. So from this expression here, you can find the change in income over the change in government expenditure. So it's simply given by this part here. So you can see, because you have done mathematics and you know how to find derivatives. So the change in income over the change in government expenditure. Remember 1 over 1 minus beta multiplies everything that is in that big bracket. So our government expenditure multiplier is simply given by 1 over 1 minus beta. So the change in y over the change in g is given by this. That is what we refer to as the government expenditure multiplier. So you should be able to derive this. And if you are given a question to compute this, you should so that is our government expenditure multiplier. So which simply tells us by how much our national income changes as a result of a unit change in the government expenditure. So we can also move and compute the tax multiplier. We have the tax multiplier also. So if our taxes changes, so remember we used lump sum taxes in our previous multipliers, like the one that we have just discussed on the government expenditure. So which we assume T is actually the lump sum taxes. Suppose now we have tax that is made up of the autonomous tax and then the induced tax. So what will be the multiplier? So if we assume that the tax is changing, then this is what we'll have. That component where we have tax, go back to the beta, that is beta t. We have beta t here. So we change that t to the change in t. Hope you can see what I mean. then our multiplier will be given by the change in y over the change in t is simply beta, that's negative beta over 1 minus beta. This is the tax multiplier. Now, we can look at a simple illustration here. So you are given the MPC as 0.8, you have y as 1160, tax is given as 40. So compute the change in income. So you can compute the change in income. So the change in income is simply cross multiply from the tax multiplier we have here. Just cross multiply both sides by the change in taxes. So you get the change in income. So that is what you have. You have beta, you have t. So if you cross multiply, this is what you have. Which is negative 160. So what does that mean? So if it is negative 160, it is telling you that the income will reduce by 160 as a result of a change in taxes or an increase in taxes. So your new income will be the old income plus the change in income, which is now 1160 minus 160, which is 1000. So that is how we compute the multipliers, and we can move on and then look at what we refer to as the balanced budget multiplier. Now, the balanced budget multiplier simply means that the government expenditure should be equal to taxes. That is, the government expenditure is equal to the government revenue. Whenever we have expenditure greater than the revenue, then we have a budget deficit. And whenever we have the government expenditure less than the taxes, then we have a budget surplus. And whenever we have the government expenditure equal to the taxes, then that is what we refer to as the balanced budget. Now, from our government multiplier, that is the government expenditure multiplier, so which we computed in the previous section, in a closed economy, and where we have taken taxes to be lump sum, so our multiplier is given by that function. So this is simply equivalent to what? 1 over beta. That is the change in y over the change in government expenditure. It's 1 over beta. That is what we found out earlier. Now, the fall in the equilibrium income due to the increase in lump sum taxes to meet the revenue needs of the government is given by the tax multiplier. This is the tax multiplier that we have computed. So the tax multiplier, in this case, the change in income over the change in taxes is simply equal to what? Negative beta over 1 minus beta. That is the tax multiplier. So this is the tax multiplier. So which tells you if the tax increases by 1 unit, then the government or the income would actually reduce by that figure. Now, if the government maintains a balanced budget, so it means that G is equal to T. So that simply means that the government expenditure equals the government income. So in this case, what will happen if we have a balanced budget where taxes are equal to revenues, or expenditure is equal to the revenues? So in this case, our multiplier is simply 1 from the change in government expenditure over the change in income. That is what we will have. So the government expenditure will be equal to 1. So that implies that the balanced budget multiplier is simply 1. The balanced budget multiplier is 1. That is true for all cases where we have a balanced budget. The multiplier is simply equal to 1. So there is an illustration here. So we have beta given as 0.75. So you can find the government expenditure multiplier. So we have said the government expenditure multiplier is given as beta, 1, given as 1 over 1 minus beta. So that implies that it is 1 minus 1 over 1 minus 0.75. This is what you have as government expenditure multiplier. We can also compute the tax multiplier from that case, so which is negative beta over 1 minus beta, so which gives you negative as the tax multiplier. So that implies that if you increase the tax by 1 unit, the income will reduce by 3 units. So we have another case now when we have the autonomous tax and when we have the induced taxes. So the induced taxes depends on the level of income. So we can also compute the multiplier. In this case, we can compute the multiplier. Now, when the tax depends on income, the tax is given as the autonomous tax, and then the one that depends on income, that is T1Y. Now, in this case, we have our national income given as consumption plus investment plus government expenditure. But consumption is made up of the autonomous consumption plus the induced consumption. So the induced consumption depends on disposable income. Now we want to get our disposable income. So the disposable income is given as Y minus T. But T is made up of T naught plus T1Y. You can take this to the equation now so that you get our consumption is actually made up of this function, which is alpha minus beta naught plus beta y minus beta t1 y. So you can go back and formulate your income function here. So you can see now our income is made up of so many components. We have autonomous investment minus beta t naught plus beta y minus beta t1 y plus investment plus government expenditure. So you can now move and make y the subject. Get the like terms together and make y the subject. So if you do that, actually this is what you will have. That is what you will have. And now our multiplier is given as 1 over 1 minus beta into brackets 1 minus t1 and multiplied by this component. Now our new tax multiplier would be given by 1 over 1 minus beta into 1 minus t. That is our new tax multiplier. That is when the tax is made up of the autonomous tax and the induced tax. So we can move to the last part of our multiplier and look at the multiplier with the foreign sector. So in all the early cases we have discussed, we are assuming a closed economy. So a closed economy means we don't have the foreign sector. We are not importing, we are not exporting. But now we can open up the economy and compute the multiplier with the foreign sector. So we go back to the income determination model, which includes the foreign sector. So in this case, our income is given as C plus investment plus the government expenditure plus exports minus imports. That is the net exports. So in this case, our investment and our government expenditure, they are fixed, and our exports too. So consumption is made up of the autonomous consumption plus the induced consumption. So the induced consumption, you can see it's made up of beta y minus t. Taxes, so the tax is made up of ty, so it is dependent on the income. And our imports depends on our level of income. So we have the autonomous imports, and we also have the part that depends on income. So from equation 1, 2, 3, 4, we can now have a comprehensive model for income determination. So our income will be given by this. So if we now include the components of each income, which is the induced and that depends on the income, this will be our income. So y will be given by this equation. We can get the like terms together and factor out y. If we get the like terms together and factor out y, this is what we will have. we'll have this equation. And our y would actually be equal to this. So we can compute the change in income over the change in investment. So we can have an extended multiplier, which includes the foreign sector. So you can look at the multiplier that we have now. So the change in investment or the change in income as a result of the change in investment will be the change in investment over 1 minus beta into 1 minus t brackets plus d. Remember, d is the the marginal propensity to import. So if you look back at your import function, d here is actually the marginal propensity to import. So our new multiplier now, our investment multiplier, can be given by this. So the change in income over the change in investment is given by this multiplier. So the change in government expenditure and the change in the exports will have the same multiplier effect on the national income as the changes in investment. But the tax multiplier will be given by this equation because of the extended model, including the foreign sector. Now, that is all about multiplier concept. I hope you'll be able to follow and compute those multipliers where necessary. So I'll give out questions on the same, which you need to compute those multipliers. Now we can move on to something else, which is the paradox of thrift. So what is a paradox of thrift? So the paradox of thrift simply shows that an attempt by the community to save more out of any given income will lead to a decrease in the actual amount it succeeds to save. That is what we refer to as the paradox of thrift. When you attempt to save more, so it will actually lead to a decrease in the amount that is actually saved. So we have this diagram that is the IS on the vertical axis, and then we have income on the horizontal axis. So we have the savings function and we have the investment function. Now, this diagram simply illustrates the paradox of thrift, and you need to understand how this happens. Now, the original savings function is S. So this is our original savings function. We also have our original investment function. The equilibrium income is Y1. So at Y1, our realized savings. So remember, where or equilibrium income is actually realized at the point where our savings equals investment. Where the savings equals investment, that is where we have our equilibrium income. So where the savings function cuts the investment function is this point here. I hope you can see it. That is where we have our equilibrium income, and we also have our the savings, which equates investment. Now, an upward shift in the savings function, you can see if the savings function, your attempt to increase your savings, they will shift this function upwards, this savings upward. So the savings function will shift from S to S plus S, which shows that, so you can see, when that function shifts. So we said that equilibrium income is realized at the level where savings equals what? Investment. So if that happens, the new savings function will cut, the investment function at this point here. So you can see the corresponding income is Y2 and the corresponding savings is S2. So S2 is lower than S1 and the Y2 is actually less than Y1. So this simply shows that the community's effort to save more leads to a new equilibrium income, Y2, and a new realized savings of S2. S2 is less than S1, and therefore, this is what we refer to as the paradox of thrift. So the community's attempt to save more actually leads to less realized savings. And I've said that it's because of that paradox of thrift. I hope this one is clear. Now, we can move to our next part. I think it is the second last, or the last part, which is inflationary and the deflationary caps. So we need to look at the deflationary cap and the inflationary cap, since we have discussed what is equilibrium in the national income. Now, an inflationary cap arises when an increase in the spending moves the economy away from the full employment position. Now, the inflationary cap is actually the amount by which the aggregate demand rises above the level necessary for full employment in the economy. That is what we refer to as the inflationary cap. So from our model we have, our diagram here, we have the consumption plus what? Investment, the government expenditure. Now, so we have the components of the national income. So we have consumption plus savings plus what? Investment. So we have consumption plus investment function. So at these levels, you can see we have C plus Y, that is C plus I minus the change in I. We have C plus I, then we have C plus I plus the change in I. So we have the change in I in this case is positive here, and the lower part is actually positive. So the expenditure functions you have seen shifts whenever we have a change in investment. Now, when the aggregate demand increases from C plus I to C plus I plus the change in I, so we have YDG, this one here, becomes the equilibrium income. But at this level here, it's unattainable since at full employment, all the resources are fully employed. Now, this implies that people have more money chasing few goods and services, and therefore we'll have a situation of excess demand in the economy. So this leads to inflationary cap, and what will happen is that the prices will go up for goods and what services. So this will push up the national income. So this will push up the national income minute. So you can solve this inflationary gap by increasing taxes, and if you increase taxes, you simply reduce people's disposable income, and then you cut the aggregate expenditure. You can also reduce the government expenditure. Government expenditure also means that less money will be in the hands of the consumers. But the deflationary gap, on the other hand, is the amount that demand falls short of the necessary level required for full employment in the economy. So when the aggregate demand falls from CI to CI minus the change in I, so YDG is the income. So you can see we have the YDG, which is here, and that is the equilibrium income. But this level is actually undesirable because it causes unemployment. You can see the level of employment has actually gone down too much, and because of this, the consumers have less money chasing too many products. Hence, there is a slump in prices and employment. Now, the difference between YDG and YF is the deflationary gap. So you can see where the deflationary cap is. The difference between YF and YDG. So if I can indicate, in fact, the deflationary cap is given by this part here. So this part is the deflationary cap. Now we can solve this problem of deflationary by increasing people's income through the reduction of income taxes. So if you reduce taxes on people, then it means that they will have more money to spend. This will generate an increase in the aggregate demand, which eventually leads to increased employment. You can also reduce prices through reduction of indirect taxes. So indirect taxes are taxes like the VAT and the excise duty. So if you do that, the prices of goods and services will go down. So you can also increase the government expenditure, and actually this will also increase the consumption. That is what we refer to as the inflationary caps. Now the floor is open for questions from your side.